Our mission is to find cures and biomarkers for Alzheimer's disease and related disorders. And our approach is utilizing cutting edge technology to profile specimens. And by specimens, I mean tissue like blood and brain from donors who generously donated themselves to research. And we profile this at a molecular level. What does that mean? So we look at the genome, we look at the alphabet that makes us who we are. We look at the products of that genome called the transcriptome, which then gets translated into protein, which makes us. And so we profile these molecules at a very fine scale in thousands and thousands of biospecimens so generously donated to research by our patients and their loved ones. Also, we are very fortunate because where I work at Mayo Clinic, and also through our collaborating institutions, we have immense information about the disease types that these patients had or have. So we have information on their clinical picture, we may have information about their brain imaging, and we may have information about their cognition, their cognitive scores. So we take this very fine scale molecular information and we take this very fine scale, let's say clinical information and other information, and we connect them through computational models. We connect them through high throughput computer models in order to identify the networks, the molecular networks that are perturbed, that are disturbed in diseases like Alzheimer's disease. Because the goal is to be able to identify what went wrong so that we can hone in on the important molecular players of what went wrong. And as those big players, big molecular players, will then become our therapeutic targets, will then become our biomarkers. My lab has been fortunate to have been funded by the NIH and other foundations since its inception 14 years ago. And through the many studies that we conducted and the discoveries that we made, we actually provided hundreds of therapeutic targets to the research field, and we are continuing to do so. The task at hand is daunting because we know that Alzheimer's disease, not only is it so prevalent, but it's also so complex. We know that Mr. Johnson versus Mrs. Stewart got their disease likely due to very different set of circumstances based on their genetics, based on their environment. So the task is vast, but I think we're up to it because from an engagement standpoint, we're there. The technology is there for us to be able to really profile the information, to really be a detective and try and deconvolute this complexity. The goal is, at the end of the day, to be able to identify personalized drugs and drug cocktails for our patients, such that using the information that we're generating now, we want to be able to parlay that, we want to be able to translate that to the clinic. And how do we envision doing that? We envision doing that by biomarkers that will help us not only diagnose but track our patients. We hope to do that by leveraging technology. We all have phones, many of us do, or other technological devices using which we can help care for our patients and we can help follow our patients in the communities. And then using the molecular therapeutic targets and information on the patients, what might have gone wrong in patient A versus patient B. We hope to be able to provide them with drug cocktails to slow down the disease and hopefully one day to stop it in its tracks. So that's what our mission and vision is about.